Welcome back, everyone. So today we're going to continue our study on statistics, and today we're going to look at. So we've dealt with sets of data in which we found different measures of center and different measures of spread. And so today what we're going to look at is an actual visual representation of a set of data and how we can pull information as from that data as far as measures of center and measures of spread. Okay, and so the visual representation that I'm referring to is called a box plot. Okay, and a box plot is a visual representation that can be drawn to show the values, how the values in a set of data are distributed. Okay, and sometimes you'll hear them referred to as a box and whisker plot, and I'll show you in just a moment why we refer to them as box and whisker plots. But first, before we even look at an example and draw a box plot, there are 5 values that you really need to have before you even begin to draw your box plot. And those values are your minimum value, your maximum value, your median value, or Q sub 2, your first quartile value, which is Q sub 1, and your third quartile value, which is Q sub 3. Okay, so whenever you're preparing to draw your box plot, you need to keep these 5 values in mind, that you need to find these 5 values first so that you can actually draw your box correctly. Okay, and so now let's take a look at an example of how we would actually draw a box plot. Okay, so we have the number of runs scored by a softball team in 20 games are given, and we want to use this data to make a box plot. Okay, so remember in our previous video, I said that when we're finding these, when we're finding the measures of center and the measures of spread, we must put our numbers in ascending order. All right, it doesn't matter when you're finding the mean or the average, because you're just taking the sum of the numbers and dividing by the total number of values that you have. But when you're finding the median or any other measure of spread, you must put your numbers in ascending order. Okay, so that's the first thing that we're going to do. All right, so first let's grab our pen. That's the first thing we're going to do. Okay, and now we want to put our numbers in order. So we have our data in ascending order. And remember, now we want to calculate the 5 important values that we need. Okay, so the first value that we need is our minimum, which is our smallest number, so that's going to be 2. The second value that we need is our maximum value, which is 14. The third value that we need is our second quartile value, or our median. Okay, and so remember in the previous video lesson, the way that I found the median was by chopping a number off of each end. And that method is fine, but when you have large sets of data, you don't want to sit there and do that, because then you'll get confused. So in a simpler way of doing it is that when, in this case, we have an even set of, or an even number of values. So we're going to take that number of values, which is 20, we're going to divide it by 2, and so we get 10. So here, our median value is going to be the 10th term, the average of the 10th and the 11th term. Whenever you have an even number of values, when you find your median, you're always going to be left with 2 terms in the middle. So you want to take the average of those 2 terms. And we saw that in the example in the previous lesson. When you have an odd number of values, you're going to have just 1 term that's going to be your median. Okay, so in this case, when we take our number of the number of values that we have and divide by 2, we get 10. So we're going to find the 10th term, which is going to be 2, 4, 6, 8, 7. That's going to be the 10th term. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7. Yes. And then the 11th term is 8. So we're going to take the average of 7 and 8. And that's going to be our median. Okay, and so the average of 7 and 8 is 15 over 2, that's 7.5. Okay, now the third term that we need, so this was our 10th term, so let me put that in another color. So 7 and 8, we found the median of that, which was 7.5. And so now we want to divide remember our median divides our set of data into the lower quartile and the upper quartile. Okay, and so one thing that I want to point out is that whenever we're dealing with our lower and our upper quartiles, we always throw out our median value. Okay, but in this case, because we have the median is 7.5 and it's not 7 and 8, we're going to throw out the 7.5, and then that splits our set of data down the middle between the two numbers that we use to average our that we use to find our median. Okay, and so in this case, our lower quartile is going to be from 7 down, and our upper quartile is going to be from 8 up. Okay, and so remember to find Q sub 1, which is our first quartile. That's the median of the lower half of our set of values. Okay, so now we want to find the median of the lower half. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, we have an even number of values. So we're going to divide by 2. So we have 10 divided by 2, that gives us 5. So now it's going to be the average of our 5th and 6th values. Okay, so 1, 2, 3, 4, 5. So it's going to be the average of 4 and 4, which is itself 4. Okay, so this is our average, our Q1 is 4. Okay, and so now, again, there's 10 terms above, so we don't need to divide by 2 again. Now we need to find the 5th term of the upper set of values. So that's 1, 2, 3, 4, 5. So the average 5th and 6th term here are 10 and 10. So the average of these two terms would be 10 as well. So Q sub 3, or our third quartile value, is 10. All right, and so now that we found the 5 important values that we need, we're going to actually make, we're going to draw our box plot. Okay, so in order to do that, what we're going to do is you're going to plot these 5 values on your line. So the minimum value is 2. So we're going to put a point at 2. Our maximum value is 14. So we're going to put a point at 14. We need our median, which is 7.5. So that's halfway in between 7 and 8. And then we want our quartile 1 value and quartile 3. Okay, so quartile 1 is 4. And quartile 3 is 10. Now, to make this box plot, what you're going to do is that you're going to draw a line. So let's change colors. You're going to draw a line, make a box actually around your quartile 1 and your quartile 3 value. So I'm going to draw a box around quartile 1 all the way up to quartile 3 and close that box. So this box includes all of our data from our quartile 1 value all the way up to our quartile 3 value. And remember that our quartiles divide our data into four equal sets of values. So if our full set of values for our data is 100% and we divide it into 4 pieces, each piece is 25%. So this box would represent 50% of our data. Okay, and so finally, what you're going to do is you're going to draw a line from that connects your median value, and then you're going to draw a line from the dot that represents your quartile 1 to your minimum value, and a horizontal line from the dot that is your quartile 3 to your maximum value. And so remember earlier that I said that these box plots are sometimes called box and whisker plots. These outside lines that connect your lower quartile and your upper quartile to your min and your max values are called your whiskers. These are referred to as whiskers. Okay, so that's why it's sometimes referred to as a box and whisker plot, because you have your box in the middle and then your two whiskers on the end. Okay, and so that is how you draw your box and your whisker plot. Now, this box and whisker plot tells you things about you. We can find certain values from this box and whisker plot. As far as, so for example, we know that our maximum value is 14 and our minimum value is 2. So we can say that from this set of data, we know that automatically our range is 14 minus 2, which is 12. Okay, we also know our median value. We can find our interquartile range value, because we know that our interquartile range is Q sub 3 minus Q sub 1. And we know Q sub 3 is 10, and we know Q sub 1 is 4, so we know that our IQR is going to be have a value of 6. Okay. Now, certain things, once we have our box and whisker plots drawn, we can also compare two sets of data with box and whisker plots, because now we have a visual representation for these two sets of data. For example, let's say we have this example where we have the box plots shown for the ticket sales in millions of dollars for the top 25 movies of 2000 and 2007. And we want to use these two box plots to compare the two data sets that we have. Okay, so remember, and the first question they ask is which data set has a greater median. So remember, our median value is located in inside of the box. Okay, so here would be our median value for the set of data for year 2000, and this would be the median value for the set of data for year 2007. Okay, and so if we want to find which data set has a greater median, we just basically look at where it falls on the number line. Okay, so from the first median would be about 125, and that would be in millions of dollars. And then the second median would be slightly below $175 million. So I would say 170. So in this case, the data set for year 2007 has a greater median value. Okay, we also want to find out which data set has the greater IQR, or interquartile range. Remember that our interquartile range is found by finding the difference between quartile 3 value and our value for quartile 1. And remember, those values are located, so this would be quartile 3, and the n values of our boxes, those are our quartile values. So this is Q1. Okay, and so for year 2000, let's just write it below here, in year 2007, your IQR is going to be, for year 2000, we have a value of 175 million. And Q1 would be a little below, a little above 100,000. So I would say maybe 105,000, 105 million. So our IQR for the data set for year 2000 is going to be approximately 70 million. Okay, and you want to find the same value for the data set of 2007. So that's going to be 245 million minus, that looks like it's 130, about approximately 130 million. So you're going to have a IQR value of 115 million. Okay, so from this we can see that the data set for 2007 also has a greater IQR. And you can see this because if you look at your box plots, the values, your box plot for year 2007 is actually shifted to the right on the number line, which means it's going to have greater values. Okay, and lastly, what we want to find out is how much greater were the ticket sales for the top movie in 2007 than in 2000. Okay, and so when they say the top movie, that means that we want our greatest, our maximum value. Okay, and remember that the maximum value is the furthermost right point on your box and whisker plot. Okay, and so for 2007, we have a max value of, it's between 325 and 350. So I would say about 335 million. And for 2000, I'm going to say 265 approximately. And do your best to estimate these numbers. Sometimes it's a little difficult to read where it actually is depending on the spacing or the increments on your number line. Okay, and so if we take the difference of these two, we get, that's 13 minus 6 is 7, so $70 million. So in 2007, the top selling movie made $70 million more than the top selling movie in year 2000. Okay, and so now we've found a way to visually represent our a data set given to us and how to pull the measures of center and measures of spread from that visual representation, which we call a box plot or a box and whisker plot. Okay, and that is the end of today's lesson.